In math, we don't like maximums, we like supremums. Let's talk about it. Let's go through the definition. A real number S is the supremum for a set A within my real numbers if it meets these two pieces of criteria. Number one, if S, my supremum, is an upper bound for A. What does it mean for a value to be a bound, upper or lower? Let's go through that. So this is just for bounded above, having an upper bound. A set A is bounded above if there exists a number B, my bound, within my real numbers, such that for every element within my set, A is going to be less than or equal to B, where A is all the possible elements within my set A. So if we visualize this, it's pretty easy. Say I have a number line and my set A. So for something to be an upper bound, for all of the elements within A, they need to be less than my value of B. So something like this would work, right? You can see that I have all kinds of A's within my set, and they're all going to be less than or equal to B. A B right here could even work, right? We have all kinds of possible upper bounds. You could even have an upper bound right here that's within my set. So I could have an A right there, and it's still going to satisfy this, right? My A is going to be equal to B if it's sitting right there. And then for all the other elements of my set, A is going to be less than B. And you can think pretty similarly when you're thinking about a set that is bounded below. So if we have a set that is bounded below, the criteria is that there will exist a number B within my real numbers such that for all A's within my set A, then A will be greater than or equal to B. So again, if we have my set, this is my set A, and we're thinking about a lower bound, then this could work, right? For all my possible A's that I could have, it's going to satisfy this. A number right here could work, right? Because then it's going to be A is equal to B, or A is greater than B. So that is what we're talking about when we're talking about upper and lower bounds. So for our supremum, then we need, for us to have a supremum, it needs to be an upper bound, specifically upper bound for A. And then our second piece of criteria says that if B is any upper bound for A, then our supremum is going to need to be less than or equal to B. So I think of this as being the best upper bound. So if we kind of visualize again what's going on with our little set right here, A, let's think about it. So we can have all kinds of upper bounds, right? That's only half the criteria, right? This could be an upper bound, this could be an upper bound, right? Because it's satisfying that criteria that the B is greater than all of our possible elements within our set. But we want the best upper bound. So for all other upper bounds, we want our S to be less than or equal to B. So you're going to see that that is going to lie right here, right? That is going to be our sup of A, supremum of A. So for all other upper bounds, my supremum is going to be the best or the least upper bound. And that's a lot of times what the supremum is referred to as. It's referred to as a least upper bound. That's kind of nice because the definition is right there within the word. And let's think of an example. We can think of, let's see, let's call our A set 1 over n, where n is within our natural numbers. So that's going to be the set of 1 over 1, so 1, 1 over 2, 1 over 3, blah, 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 blah. So you can see that the supremum for this set is going to be 1, right? That is an upper bound. All of my other elements within the set are less than that. And for all other upper bounds that I could have 2, 3, 4, anything bigger. This is going to be the least upper bound. So the sup of A here is going to be 1. And the reason we like supremums a little bit more than we like maximums is that maximums are upper bounds that are required to be within my set. A supremum can be within my set, or it can be right outside my set. So that's the reason why we like supremums just a little bit better than maximums. And we have supremums, we also have infimums. So yeah, lots to talk about here.